Multiplication and division of rational expressions. You may recall that when we multiply numbers that are fractions, that we multiply these numbers straight across. So 2 times 5 would give us 10, and 3 times 7 would give us 21. In this case, 10 divided by 21 does not reduce. On the other hand, when you have a fraction that can reduce, it is sometimes easier to do that before you actually multiply. So in this case, I don't actually know what 5 times 24 is. I'm actually going to think of this as 4 over 5 times 5 times 5 over 4 times 6. So basically I've factored the second fraction. And then I notice that I can cancel or reduce the fraction by a factor of 5. 5 divided by 5 is actually just 1, and 4 divided by 4 is 1, and my result is 5/6. So this is actually the approach we're going to use when we're multiplying polynomial expressions. We're going to factor our polynomials first and then reduce anything on the top with anything that's on the bottom. We're going to reduce that before we multiply. So here's our first example of a polynomial rational expression. I am going to first factor. Obviously this first numerator does not factor, but you might notice that the denominator here is a difference of 2 squares and factors as x plus 5 times x minus 5. Our numerator on our second fraction is just x plus 5, and this also is a difference of 2 squares, x minus 2, x plus 2. Once it's factored, I can look and cancel like factors. So x plus 5 will cancel with x plus 5 in the denominator. X minus 2 will cancel with x minus 2 in the denominator. And looks like we have nothing on the top, but we actually have 1 left on the top, divided by x minus 5 times x plus 2. Now remember, we can only cancel like factors. So you wouldn't want to start here and start canceling things. You would be canceling terms, or you would be canceling something that was part of a sum or difference. We only want to cancel things that are multiplied together. For our next example, we have y squared minus 3y divided by y plus 4 times y squared minus 16 over y squared minus 7y plus 12. So let's do the same thing. On our first fraction, we get, I don't know, this one kind of confuses a lot of people. It does only have 2 terms, but it's not a difference of 2 squares or a sum or difference of cubes, but I can factor out a y, leaving me y minus 3 divided by y plus 4 times, this is a difference of 2 squares, y minus 4, y plus 4. And the denominator here, I'm looking for 2 numbers that multiply to 12 that add to negative 7, y minus 4 and y minus 3. So I factored everything, which is always my first step, and then I'm going to cancel like factors. So y minus 4 divided by y minus 4 is actually 1. Y plus 3 divided by y minus 3 divided by y minus 3 is also 1. And y plus 4 divided by y plus 4, and our result here is just y. One thing I wanted to mention is this special quotient. If I have anything in the form a minus b divided by b minus a, our result will be minus 1. For example, if I have x minus 7 divided by 7 minus x, while they're not the same, they are opposites, and I can reduce this not by 1, but by a minus 1. So if I were to cancel an x minus 7 with a 7 minus x when I was doing my multiplication or division, I don't want to leave a 1 in its place, I want to leave a negative 1 in its place. Let's take a look at another example. We want to talk about division. When you divide two fractions, a divided by b divided by c divided by d, we can change the second fraction by taking its reciprocal, d divided by c, and changing our division to a multiplication. Sometimes we say, keep it, change it, flip it. All right, we've got 2 minus 3x divided by x squared plus 8x plus 12 divided by 3x squared plus x minus 2 divided by x squared plus 7x plus 6. As always, we still need to factor. So I'm going to start by just rewriting my first numerator, 2 minus 3x, and I'm going to factor this expression, two things that multiply to 12 that add to 8. We will get x plus 6 and x plus 2. I'm going to change this to multiplication, and I'm going to switch where I write these two. So I am going to factor the denominator here. It's two things that multiply to 6 that add to 7, x plus 6 and x plus 1. But notice that I wrote it in the numerator. This last one might take a little more to factor it because our coefficient is not a 1. So I'm going to multiply the 3 times the negative 2, and I'm looking for factors that would multiply to negative 6. So we know 1 times 6 or 2 times 3. And we notice right here that if I have a plus 3 and a minus 2, those two will add to positive 1. So I am going to factor using these two numbers. And if you've watched one of my other videos, what we're going to do here is the voodoo method. I'm going to divide each one of these by the lead coefficient, 3 right here. And I'm going to reduce each of these fractions, negative 2/3 and positive 1 over 1. And I'm going to bring those denominators up, giving me my factors, 3x minus 2 and x plus 1. So everything is factored, and we've changed our division into a multiplication, so we treat it exactly like we did previously, canceling like factors. X plus 6 and x plus 6 will cancel out. X plus 1 and x plus 1 will cancel out. And here we have 2 minus 3x and 3x minus 2, which, as we just talked about, we can reduce, but in their place we have to leave a negative 1. So what do we have left here? We have negative 1 divided by x plus 2. Have a super fantastic day. That concludes this lesson.